John here, Intelligent Concrete. We're doing some mixing and I look like a rhinoceros. This is our second of third video on our road patch. And what we've already gone over is the mix design that we're using. And what we're going to be doing now is the actual mixing process and the casting of samples. And our samples are easy enough. We're going to be using these 3x6 inch cylinders, storing them in our semi-adiabatic temperature device, letting them cure up over 4 and then 24 hours, and then we'll show you all the data as well as doing some breaks. But for now, what we wanted to show you is our organization process when it comes to setting up mixes, and we are very particular. We don't have a lot of real estate in our lab, so every square foot matters and how we use that square foot matters. Going down to how we collect our materials and store them in preparation for our mixes. So what we've already shown you is that for our standard mix, we're only using about 4 materials, or sand, cement, water, and our high range. So it's not really hard to organize that, but when we look at our higher performing fast track pavement, we're using 3 more chemicals. So it starts becoming a little bit more confusing, especially when you look at how the changes in materials go from mix to mix to mix if we are doing a whole series. Now, please bear in mind, when we're doing this mix and we have all our proportions, a lot of mixes went before this mix, and I believe this was iteration number 18. We're looking at trying to achieve these fresh properties as well as these strengths, and this is just a truncation of that whole that development project, if you will. Okay, so the way we separate it out, and you'll see here in a second, is very specific. We number all of our mixes in our batch sheets, and every vessel where we're holding one of the raw materials has that same number designation to it, as well as some form of the name of that component of our composite, whether it's grout or it's concrete. So let's go ahead and take a look at it. We'll do a time lapse, but I really want to get to mixing and making, so you're awesome. for joining us today. We did a whole bunch of mixing. We got 2 mixes done, and what we were trying to show you was the difference in sequencing. But what we wanted you to see in the second set of mixes, or the second mix, we had 3 more chemicals to add. So we added our accelerator with the water. So accelerator went up front. And then after all the particles were wetted, we threw our high-range water reducer, as high-range water reducers normally go in. And then we gave it about 15 to 30 seconds to mix, and then we threw in our hydration stabilizer. Now once we did this, our mix started to let go. That hydration stabilizer, high-range water reducer combination really gives us that ability to go to a lower water cementitious ratio while still having a mix that had a good fluidity or workability to it. Our final constituent was our colloidal silica, and we threw that in after we saw a nice fluid mixture. If you're throwing it into a tight mix, you might get some pore dispersion, so you want to make sure your mix is totally let go before you put in your colloidal silica. Now, after we got done mixing, we also made some samples. Well, we tested our slump, and using our mini slump cone, we found our slump to be, for the reference, 5.5 centimeters. And then for the high performance road patch or fast track pavement, we had 5.9 centimeters. So not really a huge variation, and the mixes looked reasonably the same. They also had the same stickiness to them, and let's go ahead and overlay that video of that sticky and icky mix as we finished it on the top surface. Thank you, Patchouli, for doing that. And that's something that we needed to address. You know, these high performance mixes, whether we're looking at our standard version, which still gives you a reasonable amount of strength at that 4 to 6 hour mark, which we're going for, but the second mix where we're actually hitting that 4 to 8 hour mark, it still had that stickiness. Now we had a little bit more chemistry in there, and some of that chemistry was used to make the mix creamy and dreamy, but when it comes down to it, when you're using the type of materials and the content that you're using, you have to sacrifice something. You're still getting that workability, you're getting that window, and you're getting your high early strength. One of the things to normally go when using these fast track pavements or fast track concrete mix designs is that finish ability. And that's one thing that we tried to show, is that mix, both of them, were really icky and sticky. The surface dragged, it tore open, and then if we finished it a little bit and pulled it up top, you saw those icicle forms. And again, that's not that creamy and dreamy that we normally like, but again, that's something that has to be sacrificed when we're going for those higher performing features and benefits. Now, a way to get past that is by using finishing aids, and we've got another video about that. We'll put that in the section below. So thanks a bunch for your time. Let us know if you got any concrete questions or concrete concerns. We're going to be breaking some cylinders. There's no watch. I've got no watch here. We're going to be breaking, and I still did it. We're going to be breaking some cylinders here, I believe somewhere between 4 and 8 hours. It might be at the 6 hour mark. I'll go check the paperwork, but next time you see us, we'll be doing a video. It'll be dark out. We'll be looking at the semi-adiabatic temperature device, as well as the compression machine breaking some concrete. Go concrete! Beat asphalt!